Look at almost any old farmhouse, warehouse, or factory roof, and you'll find the same little spinning silver dome. It turns on its own. It has no motor, no wires, no switch, and it has been quietly pulling heat out of buildings for over 100 years for free. So here's the strange part. Walk through any brand new neighborhood built in the last decade, and you won't find a single one. Something that worked, that cost almost nothing to run, simply vanished from the roofline. If you're the kind of person who likes knowing how the world actually works, instead of just accepting that it does, stay with me, because the reason this thing disappeared is far more interesting than the thing itself. What you're looking at is called a turbine ventilator. Most people who grew up with them just called them whirlybirds. The science behind why it spins isn't magic, and it isn't a gimmick. When wind passes over the curved vanes of that little dome, the air is forced to speed up, and when air speeds up, its pressure drops. That drop in pressure creates suction inside the turbine, and that suction reaches down into the attic and drags hot air up and out. The faster the wind blows, the harder it pulls. It's the same principle that lets an airplane wing generate lift, just turned on its side and bolted to a roof. And here's the detail almost nobody knows. The turbine doesn't actually need the wind to keep working. Even on a dead still summer afternoon, hot air in your attic is lighter than cool air, so it rises naturally and escapes through the turbine on its own. Engineers call that the stack effect. The spinning is just the bonus. So you have a device that works in the wind and works without it, drawing on basic physics that never sends you a bill. This raises an obvious question. If it's that clever, where did it come from? And why did we ever forget it? The idea of cooling a building with nothing but moving air is ancient. Persian builders were doing it more than 1,000 years ago, with tall mud brick towers called badgirs, designed to catch the desert breeze and funnel it down into the rooms below. But the spinning rooftop version we recognize today has a precise birthday. In 1910, an engineer named Samuel Ewart patented a rotating cowl that sat on a roof and actively pulled air out of the space underneath. His patent didn't even sell it as air conditioning. He pitched it as a fix for chimneys that blew smoke back into the house on windy days. The cooling, it turned out, was almost a side effect of solving a completely different problem. I'll be honest with you, when I first read how well these things actually perform, I assumed the numbers were marketing. They aren't. Independent testing in the San Diego area found that a properly installed turbine system dropped peak attic temperatures by as much as 37 degrees Fahrenheit. That same study measured an average cooling bill reduction of just under 15%. And this matters more than it sounds, because the US Department of Energy estimates that every single degree your attic heats up can raise your cooling load by up to 4%. An overheated attic isn't a separate problem from your electric bill. It is your electric bill. To put real numbers on it, a standard 12-inch turbine moves somewhere between 250 and 350 cubic feet of air every minute in just a 5-mile-an-hour breeze. Step up to a 14-inch unit, and you're pushing as much as 500. The hardware to do this costs as little as $20. So we have a documented, tested, dirt-cheap device that lowers your power bill and even extends the life of your roof by keeping the deck cool and dry. Everything about that should have made it permanent, which makes its disappearance genuinely puzzling. And the answer comes down to 3 things nobody puts on a sales brochure. If you find yourself wanting the real story behind the everyday objects most people never think twice about, this is exactly the kind of thing this channel exists to dig into. The first problem is the very thing that makes it special. It spins. That spinning head sits on small ball bearings, and bearings wear out. Moisture, dust, and a lack of grease eventually turn that silent dome into a squeaking, grinding noise that travels straight down through the roof and into the bedroom below. Cheap units failed fastest, and over the years, that earned the whole category a reputation as noisy and unreliable. Fair or not, a device with no moving parts can't fail this way. A turbine, by design, always can. The second problem is sneakier, and it's pure engineering. If a builder installs a turbine and a long ridge vent on the same roof over the same attic, the turbine pulls so aggressively that it can actually reverse the ridge vent, sucking outside air, rain, and even snow back into the attic instead of pushing hot air out. So roofers learn to pick one or the other, and because a ridge vent is faster to install and hides invisibly along the peak of the roof, the turbine became the one that got dropped. It wasn't beaten on performance, it was beaten on convenience. But the third reason is the one I find hardest to argue with, because it has nothing to do with how the device works at all. It's how it looks. A turbine sticks up off the roof and is visible from the street. And in the American housing market, a clean, uniform roofline quietly drives up property values. Homeowners associations across the country started restricting or flat-out banning whirlybirds for ruining that look. Even in Florida, where state law is supposed to protect energy-saving devices, some associations got around it by demanding the turbine be mounted only on the back slope of the roof, the side that often faces away from the wind. The result is a device deliberately installed where it can't do its job, kept legal but rendered useless. There's also a quieter, more bureaucratic killer. As new homes got tighter and more sealed for efficiency, building codes like California's Title 24 began requiring mechanical ventilation systems that guarantee a precise, controlled rate of air exchange. A turbine can't promise that. Its output rises and falls with the wind, and you can't certify something you can't control. So a device that asks for nothing and runs forever quietly fell into a regulatory grey zone, edged out not because it failed a test, but because it couldn't be measured the way the new rules demanded. So, should you put one back on your roof? The honest answer is that it depends on where you stand. If you live somewhere hot and windy, the Gulf Coast, the Southwest, much of the Sun Belt, a pair of turbines on a typical attic can pay for itself in energy savings within 3 to 5 years and protect your shingles on top of that. But if you live somewhere cold, that same spinning head can freeze solid in winter and seize up exactly when you don't want a hole in your roof. The device never stopped working. We just changed the world around it, with tighter homes, stricter codes, and neighborhoods that care more about the silhouette of a roof than what's happening underneath it. Somewhere out there, a 115-year-old patent is still spinning on an old barn, doing for free what we now pay a power company to do. So here's the real question. Was the whirlybird a genuinely good idea we abandoned for all the wrong reasons? Or was it a flawed relic that deserved to disappear? Tell me which side you land on. And if you'd rather understand the hidden history of the things around you than just walk past them, this is the channel for that. So come along for the next one.